It's all your fault. You did this to me. So this is the clock that started it all. 2017, I set out on an adventure with an idea, and this is what I ended up with. And from that day, we moved forward to all the other videos you may have seen. This is the first clock I built. You can see we have a little issue here. It's been running flawlessly for many years, and we're going to dig in and see what's going on with that half of the colon and review what it took to get this thing together, what you see before you. And here we are with the top cover removed. A little gander at the inside. And our problem LED is located in here. We'll get to that in a minute. I figured I'd do the geographical layout here. Okay, so we have our transformer, rectifier section, capacitor for filtering, and we have our 1 second pulse going here, represented by the LED, our divider section for the 60 Hertz division, and then this guy here, Schmidt trigger, which is used for pulse conditioning and or button debouncing for time setting. These are our RC networks for our button debouncing, to be able to set the time so you don't have chattery outputs. That way you can advance the time 1 digit at a time cleanly. Connections are brought over to the next board. This is our hours counting section, 1, 2, 3, and I think there was an extra flip-flop to be able to have an AM PM indicator. This package here is used for blending the time setting outputs. It's a OR gate 7432, seconds, minutes, and more of the hours section. Our display drivers, our display resistors, 1 resistor for each segment, and then our connection to our display board. Over here I have brought BCD up to these connectors here, which then loop up to these D-sub connector on the back here. Let's get into what's going on with this LED. I'll probably shut the clock down and just remove a few pieces, as this clock comes apart very easily. And now we have the clock disassembled into its individual sections. I use a DMM to check the LEDs. I think I'll probably end up changing an LED, and we'll see. Busy, busy, busy. And we have a little hot glue to remove. With any luck, it's just a cold solder joint. But I have a feeling these high quality China LEDs may be at fault. Or maybe a resistor here. Looks like the solder joints are fine. So I'll probably be changing an LED. So I changed them both. We can put this back together now. I'll put a little maybe hot glue back on this. I might not need it. Bic ballpoint pen standoffs for the board. Yeah. All back together, looking good. Couple of colons. So this is all of the notes that I have for this clock. This is the one that started it all, as I said in the beginning. The collection has grown to several clocks now. The searching on eBay and other places is at times constant. I have pulled back from it a little bit, but at any rate, let's just talk about this very clock that I learned a lot from in the build. I went ahead and wrote up a theory of operation, so power supply and pre-scale and the seconds, how all counters work. And from school I remember the 7493. A lot of the clocks I build now I use 7490s, maybe the 7492, which automatically counts to 6. But you can set these to reset at any point, in which case this clock uses the 7493. We'll get to that in a minute. But apparently these notes are looking at LEDs, maybe the colons, some transistors, which I was new to. Having not a lot of experience in many years, so I was playing around with different circuits and calculations. We're just going to go through this quick because this can get very long, I fear. I think I was adding up all the packages. There's 18 packages in this clock. That means that's a lot. So you start adding up the currents and then the LEDs. Could be pushing almost an amp, this thing. So the power supply had to be pretty stout, right? So again, just whipping through. Let's see, here we have, I think this is the dividing section to divide the line frequency down, and I know, it's like, okay, this is the one I'm going to use. Okay, 7490, 7492, and then you get your 1 pulse per second. Schmidt trigger in to clean up any miscounts. That seems to be working. This thing counts really cleanly. I put this up against other line-based clocks I have, and it stays within a second of all, stays exactly the same as all the other ones. Uh, 0 to 9 counters. Let's fix that shadow, sorry about that. So 0 to 9 counters. 7492, 7490, clock to the next stage. Okay, so the clock signal comes in and goes out. This looks like a 0 to 5 counter. But I think I used the 7490 in the first stage, and then 7493s after that for the rest of the seconds and minutes. Hours section, I did something different. I used this one because of the time setting method I used. We'll get into that in a minute. The other thing I noticed here, I apparently used 7408 gates for reset. These counters have their own built-in gates, so I don't know why I did that. That's an extra package I didn't need. So that's interesting. So the 7408, why did I do that? I was learning, so I definitely streamlined this build after this first one. Like I said, I learned a lot in this. Okay, I said the hours section, I did something different. I didn't know how to make the 7490 series chip as a 1 in 12 counter. That was the big struggle with this clock. We had to make a 1 to 12 counter, and using a pair of 7490s, for example, in the hours section, there is one position when you go to reset the one counter, you got to get a 0 out of the count. I couldn't figure out how to do that using the 7490s, but in this case I used 74LS107. I think I picked that one because it was negative edge triggered. I have notes here for that. But flip-flops, JK flip-flops, and JK flip-flops, 7408, 7410. It looks like a NAND gate, whatever that would be. So yeah, got a couple different logic packages in here to make the 1 to 12 counter. I'm not going to go through how this exactly works, but boy, I'd have to redig this in my brain. But I figured this out somehow as a really green novice. There was some poking around on the internet that might have steered me to this, but in the end I made it all work. And I think there was an extra gate somewhere where I could do an PM indicator light in case I wanted to bring an alarm off of this clock. But here's the counts over here. A lot went into this. Pulse shaping. These counters, the 7490s and others, want what's called noiseless or debounced switch contacts. And the only way to do that is to do a RC network. And in this case, I also fed that output for the RC network into a Schmitt trigger, which really provides a nice snap action result, giving you a nice pulse. So the way this works, you press this button once and it generates one pulse and you're done. So for time setting, you just keep pulsing the switch to advance the count to set the time you want. This circuit design did not blend in the time reference like other clocks I have do. They blend in the time reference and you just hold the button. In this case, you actually, to advance the time for time setting, you keep pressing the button on and off and you generate one pulse per press. So that was kind of unique for me to figure out in this clock. And here's pretty much the block diagram of how that works in each section with separate button debouncing circuits through the 7414 through the 7432, which is an OR gate, I believe, and then clock signals would also come into that 7432, and they would blend nicely and worked with the 7493s, and then the hour section, which I used the 74 LS107. Again, only a pin out. And then when you start building, you map it out. This is the board with the transformer on it. Rectifier section, smoothing cap. I used the Murata switching regulator. I remember when I first put this together, I had it on the perf board with a heat sink, and that's 7805 was cooking hot, and I was like, I'm gonna smoke something. And then that's when I first found out about the Murata switching regulator. I put that in, and boy, that runs nice and cool. That does the job. Voltage divider over here for the signal, the beginning of the signal conditioning. And yeah, so that comes in more conditioning with the 7414 frequency divider and the blinking LED, and out. All the connections are done with those screw terminals to the logic board on the other side, and that's all blocked out. And this all aids in like future repairs. So having the hours counter and driver display section and minutes and seconds all blocked out, so you know where to go to in case of an issue. And you saw the back side of that logic board. It's a rat's nest. I built this thing and connected it up, and it worked. I could not believe it. I remember that day. Anyway, these are it's the placement of the logic packages, and you see top view. Then over here, this is the solder side. So to do perf boarding, you got to draw everything upside down and backwards, and then do your pin outs and stuff like that backwards, and then you don't have to flip the thing back and forth and get lost. It really streamlined the build to be able to read the point-to-point wiring backwards. So that's what this was. This is the circuit as a whole, schematic. So if we do any troubleshooting, this is where we gotta go. But yeah, the resets for the 0 to 5 counters using the 7408, I wasn't thinking you could actually just loop these around and use the onboard AND gate to be able to reset this back to 0. The 7490 resets to 0 on a, because that naturally counts 0 to 9, but this is a 0 to 15 counter, and this one as well. But they have their onboard AND gates. So why I use the 7408, I don't know, but it did come in handy in this section. There's an extra gate needed for that, so maybe that's why. Couple findings after the build. I had red LEDs as colons, and with the blue, you know, I dreamed to use the blue 7-segment displays. What a clash. It was hard for the eyes to look at that. It's a different wavelengths of light didn't work, so that's why I later on put in blue LED colons, have the display consistent. I added some display dimming with a potentiometer. Alright, a few other things. When it's extremely dry in the house, wintertime, walk by with a laundry basket. The thing did jump a count in the hours section from the static. So all that point-to-point wiring on a logic board, and you read in TTL books, that's a no-no because they act like antennas. So, but the clock is entirely stable if it's put aside, and it really hasn't skipped a beat in many years. Just don't walk by with a fresh basket of laundry right out of the dryer. I put a provision to take binary counts out, and I actually had it hooked up to another clock just with the binary driving another I think a Numatron display. It creates a lot of instability. Again, you got a lot more antennas and stuff, so that didn't really get used. And I added a time hold button later on. And the display drivers, the 7447, a lot of you are familiar with, they had another version, the 74247, and that puts the tails on the 6s and the 9s. So it just decodes the display a little differently, and some people like the top on the 6 and the bottom on the 9, and that's the 74247 that does that. This is the output of the D-sub connector, which I'm not currently using. And again, another breakout of the 1 to 12 counter. This is, I guess, the first chicken scratch I did, and this is the point-to-point on that. And these are other button debouncing circuits I was looking into using a multi-vibrator. I think they call it the 74123, and this works reasonable but not perfect. Tried different cap values, do not use, and that's when I use the other one, using the 7414, yes. And this is my attempt in blending it in the first time with the 74123. Another time setting circuit attempt, and then the start of the build, and this is the dimensions of the overall clock. Well, I hope you enjoyed that quick run through of my chicken scratch. If you're still watching, thanks for watching. Hope you enjoyed. Maybe you got something out of it. But we have another special clock coming in the mail today. I'm going to get that up and running and share that with you guys. And the last video was the IV11 VFD tube clock that I built, a double-decker with a green perf board. And that one has been put on hold just for the case. Because it got so cold out. We were -8 the last couple of days here, and when we woke up in the morning, and I'm not going out in the garage and running the heat. Just gonna wait on that, building that case. So you'll see that in a future episode, all buttoned up when we get to that. And like I said, hope you enjoyed. See you in the next one.